11 methods, we're going to look at the practice test. I'll just go over the whole test. Okay, so question 1. Consider the following table. We want to find the probability or find the value of k. Okay, so we know that probability distributions add up to 1. So we've got negative 5k's equal to 1. So you just solve for k. So that's negative a fifth, which equals negative 0.2. Question 2, same thing. I want to find the value of k, so we know that adds up to 1. So 0.5 plus 2k equals 1. So 2k equals 2.5. K would equal 0.25. So the answer is E. Question 3, we want to find the probability of x being between 3 and 5. So we just add, including 3 and 5. So we just add these probabilities together. So 0.3 plus 0.24 is 0.54. 0.54 plus 0.08 is 0.62. So the answer is A. Question 4. Okay, we have a spinner shown. If x is the number indicated by the spinner, find the probability distributed of x. So what if x is the number indicated by the spinner, we've only got two numbers. So x could either equal 1 or 2. The probability of x being 1 would be 1 out of 4. The probability x being 2 would be 3 out of 4. So 1/4 and 3/4. So the answer is B. Question 5. Suppose there are 3 balls in a bag, 1 white and 2 black. So 1 white, 2 black. A ball is drawn from the bag and its color is noted. If the ball is white, then the ball is not replaced and a second ball is drawn. If the color is noted, then the process is repeated until a black ball is drawn. If x is a number drawn before the black ball is drawn, what are the possibilities of x? So in the first draw, you can get a white ball, okay? And if you get a white ball, then you have to draw a second time, okay? And the second time will definitely be a black ball because there's only 3 balls in the bag, and if you draw a white to start, then you have no option to get a black. So your x would be 1. Now, if I draw a black ball at the very start, then I've drawn no other colored balls beside a black ball. So it says x is the number of balls before a black ball is drawn. So if I draw a black ball at the very start, then I haven't drawn any balls before a black ball is drawn. So your x can be only 2 options, a 0 or a 1. Okay, so the answer is B. 7, a 6-sided die is rolled 4 times. Find the probability of 6 showing at least once is closest to it. So these are independent events, so it's binomial. Now the probability is a 6 to rolling a 6 on the die. Our num trial is 4 because we're rolling the die 4 times, and we want to and we let x as being the number of 6s rolled. So we want the probability of x to be, it says at least once means greater than or equal to 1. Okay, so I'm going to use CDF on the CADS calculator. I'm going to go discrete binomial CDF. I want it to be 1 to 4 because my options for least once means 1, 2, 3, or 4. Num trial 4, and the probability is 1 divided by 6. So the answer should be 0.15177. So the answer is C. Question 8. Which of the following discrete random variables has a binomial distribution? So the number of times an even number is observed when a fair die is rolled. Okay, that actually looks plausible. The number of rainy days in a row before a sunny day is observed? No, not quite, because this is sort of unbounded. Okay, meaning that you could have a million rainy days before a sunny day is observed. The kilogram weight of a randomly chosen student? No, because that varies too much. It's like it's known as a normal distribution because the weight kilogram of students follows a bell curve. Okay? Number of people in a football match again it can follow a bell curve. The diameter of tomatoes grown in a bush, again, this can follow a bell curve. So the only plausible option is A. So I'm going to choose A. Question 10. At a certain hospital, the probability of child being born is 0.52. If 100 babies were born on a certain day, the probability that fewer half than babies is closest to. So it's binomial because the probabilities of babies being born, whether male or female, is not affected by the previous one. Now, why would the probability of females being born be 0.52? I suppose there's no most particular reason. It's just a test question. But I know in some countries they do selective abortion, so that might skew the results. So my N is 100, my num trial is 100, my P is 0.52, and X is the number of females being born, and we want fewer than half these females being, fewer than half means fewer than not including 50. So X is less than or equal to 49 equals to, we're going to use CDF. So we're going to go interactive, distribution discrete, binomial CDF, 0 to 49, num trial is 100, and the probability is 0.52. It's closest to, oops, it's closest to 0.3081 or 308, 30816. 382, so 382, so E is the answer. Okay, question 11. Steve passes through a three sets of traffic lights to work. The probability of him having to stop any traffic lights 3/8, and it's independent of whether he stops any traffic. So it's independent means binomial. Okay. The probability that he drives all the way without stopping traffic light is, now the number of trials is 3. Okay, because there's 3 traffic lights. The probability is 3/8, so the probability of stopping any traffic lights is 3/8. The probability that it drives all the way without stopping, so we want X. If X is the number of stops, we want no stops, because in order for him to pass, he has to not stop any traffic lights. So I'm just going to go binomial, PDF. X would be 3, no, not 3, 0, sorry. Num trials will be 3, and the probability will be 3/8. 0.244. Now, if you can't get, if the answer is a fraction and you've got a decimal, what you can do is you can test which one it is. Okay, so you can go 3 divided by 8, that's not it. 27 divided by 512, that's not it. 5 divided by 8, 5 divided by 8, that's not it. 125 divided by 512. Let's go back. What did I get? 2441. Yep. So the answer is D. Okay. So if you can't get the correct answer, that's going to be what you want. Okay. Just in case you're wondering, how do they get exact answers? They've just drew a tree diagram basically. Okay. So we know that the probability of stopping is 3/8. Not stopping would be 5/8, and you want 3 not stops. 5/8 divided by 5/8 divided, not divide, 5/8 times 5/8 times 5/8, so not stop, not stop, not stop. So 5/8, so if you were to do this times 5/8 times 5/8, you would do this by, by doing a tree diagram. That's how they got their answer. Okay, just in case you're wondering. So binomials to work. Question 13, 15. The probability of winning a single game is 0.2, whether or not the game is won is independent of each other, so it's binomial. Suppose Nathan plays 6 games, the probability he wins 3 or 4 times, it's closest to. So I'm going to use binomial CDF. So lower would be 3, up would be 4, He plays 6 games, so number 12 6, and the probability of 0.2. So enter, so 0.0973. Okay, so that's B. Suppose Nathan plays a sequence of n games, there's probably at least one game is more than 0.5. The smallest value of n. Okay, so if suppose Nathan plays a sequence of n games, it's probably winning at least one game is more than the smallest value of n can take. Okay, so we're going to have to try different values. Okay, so this is basically a trial and error type question. So I'm going to use discrete. Smallest value of n, at least one game. Okay. So we're going to have to use trial and error. So I'm going to use CDF. So let's see which one gives you a probability of more than 0.5. So at least one game means 1 to another number. So we'll try 29 first. Number of trials would say be 29. And the probability of winning 0.2. So let's just see which one gives me, okay, that works. We'll do 28, see if that works as well. So if I go 1 to 28, that works. The smallest value, so 1 the smallest value, so we'll try 14, see if it works. So if I win 1 to 14 games, does that give me, yep, that works as well. We'll try 11. Okay, 11 doesn't work, so 14 will be my lowest number. So if I use CDF, if x is between 1 to 14, then that works. That gives me a probability of 0.95 because that's a smallest value. Question 15. Suppose Nathan plays another sequence n game. It's the probability of winning at least 2 games is more than 0.95. The smallest value you can take is. So I'm going to use CDF. If now you're going between 2 to 2 or more games, 2 to the smallest value. Smallest value means you're going to try all these values and see which one works. So if I go 1 to 5, 2 to 5, and the maximum is 5, would that give me a 0.95? No, that's not right. We'll try 29. Yep, that works. We'll try 22. It's 22. Yep, 22 is the lowest. That works. 22 is the lowest that works. Okay, I've got a short answer questions. For the following probability distribution, calculate probably less than equal to 3. So less than equal to 3 would be 0.1 plus 0.2 plus 0.3 plus 0.2. That's 0.5, 0.5, that's 0.8. 0.8. Probably greater equal to 2, 0.5, 6, 7.7. And probably between 2 and 4. 2 and 4, 0.5, 0.6. Question 2. Find the value of k. So add all the k's together, add up to 1. So 2, 4, 6, 8, 10, 11. K equals 1. K equals 1 on 11. Okay. Question 3. A jar contains 1 red marble, 4 green, and 15 white. So if 1 marble is drawn from random, if red, Joe wins $10. If green, he wins $1. If it is white, it doesn't win anything. Okay, so your x's could be 0. So your x represents the amount of money he wins. He could win $1, or he could win $10. Okay, so if it's white, he doesn't win anything. If it's green, he wins $1. If it's red, he wins $10. Okay, so what's the probability of it being so here's the probability distribution table for. Okay, 1 marble is drawn random from the jar. So what's the probability? How many marbles are there? 4 plus 15, 19 plus 1. So it's 20 marbles in total. So what's the probability of getting a white marble? A white marble would be 15 out of 20, which is 3/4. The probability of getting a green marble would be 4 out of 20, which equals 1/5. And a red marble, there's one red marble, so it's 1 of 20. Okay, so you'll find that that should add up to, oops, that should add up to 1. Okay, so just double checking, that's 15 out of 20, that's 4 out of 20, and that's 1 out of 20. Okay, so a jar contains 2 mints and 3 toffees. If 2 sweets are selected random from the jar for replacement, okay, well, for replacement is a key word, so it's not binomial anymore. It's going to be hypergeometric. X is number of mints selected. What's the probability of X? Okay, so how many mints are there? There's 2 mints, so you can select 0, 1, or 2. We're going to use the binomial distribution. I'm going to use PDF. Now my x is going to be 0 at the start because I want to find the value of x equals 0. My n is going to be, how many am I selecting? I'm selecting 2 sweets from a jar. My m, how many mints are there in the original population? 2. What's my total population? Contains 2 mints, 3 toffees, so it's 5. So I'm going to click enter. So it's 0.3. And if I go 1, I get 0.6. And if I go 2, I get 0.1. Okay, so that's how you fill it in. A binomial distribution, n is 4, p is 0.2. Find the probability of 3 successes, 3 or more successes, or at most 3 successes. Okay, so you're going to have to use binomial. For the first one, PDF. So you want 3 successes, the number of trials is 4, and we want the probability of success is 0.2. Enter. So it's 0.0256. 3 or more successes. So you just go discrete CDF. 3 or more means 3 to 4 because there's only 4 maximum. Number of trials is 4. Probability is 0.2. Enter. 0.0272. 0.0272. And at most 3 successes, meaning you want it from 0 to 3 because you want at most 3 successes. 0.9984. Okay, and you're done. Now, expand question. So, Kira is in charge of quality control at her company. She decides whether to accept the delivery of potatoes from a supplier. And to do this, she must test some potatoes. She tests enough potatoes to see if the batch is acceptable. As the potatoes are destroyed in the process of being tested, she must not test too many. She wants to ensure she rejects batches in which more than 10% of the potatoes are defective. So a sample inspection is devised as follows. A sample of 30 potatoes drawn from a large batch of potatoes, and all 30 are tested. Okay, so my n is going to be 30. If a sample contains two or less than 2 defective potatoes, the batch is accepted. So if it's 2 or less, they accept it. If the sample contains 3 or more, it's rejected. Suppose 10% of the potatoes are effective. What's the probability of batch being rejected? Okay, so really important. My n is 20. My probability is 0.1. And we want the probability of x. Rejected means contains 3 or more. So if x is greater equal to 3, then it's rejected. So we're just trying to find the probability of x is greater equal to 3. So I'm going to use distribution discrete binomial CDF because we want it between 3 Now the upper limit is 30 because we're only testing 30. The number of trials is 30, and the probability of being defective is 0.1. So it's 0.55886. Okay, 0.5886. Okay, a friend suggests that she use the double sampling plan. A sample of 80, not 80, a sample of 20 potatoes drawn from a large batch of potatoes and all 20 are tested. If the sample contains no defective potatoes, the batch is accepted. If the sample contains 2 or more defective potatoes, the batch is rejected. If the sample only contains 1 defective potato, a further sample of 10 is selected and tested. If any of these is defective, then the whole batch is rejected. Suppose that 10% of the potatoes are defective. So what is the probability that the batch is rejected in the base of the first sample? So the first sample, you've got 20 potatoes. It's accepted. Then we have no defective potatoes. Okay, so if it contains 1 potato in the original sample, then we have to retest. If it contains 2 or more, then the batch is rejected outright. So to get the probability, we do this. We go discrete. I'm going to go PDF because the only way the first batch of 20 is accepted is there's no defective potatoes. There's 20 tested, and the probability is 0.1. So my answer is 0.1216. Oh, actually, no, not. Hang on. What's probably is that the batch is rejected based on the first sample. It's not, sorry, not accepted, rejected. If the sample contains 2 or more defective potatoes, then the batch is rejected. Okay, so the original batch is. So I misread the question. Make sure you read the question really carefully. So I'm going to go binomial CDF. Okay, so it says it's rejected if it contains 2 or more defective potatoes in the original batch. So 2 or more means 2 to 20 because we're only testing 20. Num trial 20 and the probability is 0.1. Okay, so 0.6083. 0.6083. What's the probability that the second sample is drawn? Okay, when is the second sample drawn? If the sample contains 1 defective potato, then a second sample is drawn. Okay. Just be right back. I'm going to have to plug in my laptop charger. Okay, so okay, so for the probability of second sample being drawn, so if the sample contains 1 defective potato, if the original sample contains 1 defective potato, then a further 10 is selected and tested. So second sample is drawn if we have 1 potato that's defective in the original sample. So I'm just going to go discrete, PDF, 1, num trial 20, and the probability is 0.1. Okay, enter. So 0.2702, 0.2702. So part of the trick is just to read the question properly, like all the information is given there. What's the probability that batch is rejected on the basis of the second sample? So if you read the question carefully, if I do take a second test, which means I take a first sample of 10, if any of these are defective, then the whole batch is rejected. So what's the probability that's rejected on second sample? Okay, so it'll be binomial CDF. Well, it's rejected if there's any defective potatoes in the 10. So 1 to 10, anything apart from 0 will get it rejected. Okay, so we got 10 potatoes and the probability is 0.1. Enter. So it's 0.6513. So 0.6513. What's probability that the batch, okay, so what's the probability that the batch is rejected on the basis of the second sample? What is the probability that the batch is rejected? Okay, this is a very good question. Okay, so you can think of this as like a tree diagram. Okay, so if you got rejected in the first sample, you're rejected outright. But if you got rejected, if you got you can get rejected, you can get accepted, or you can get retested. So if you get retested, you can either have rejected or accepted. Okay, so what's the probability that the batch is rejected? Um, you can have rejection twice. Okay, two ways. You can have an outright rejection in the first from the first sample, or you can have a rejection by having a test or a retest and then a rejection. So what's the probability of getting rejected on the first sample? It's 0.6083. So I'm just going to use that probability. So that's because that's the first branch. And the second branch, what's the probability um, of getting rejected on the basis of the second sample? Okay, or what's the probability of getting rejected? So if you get what's the probability that the second sample is drawn? So the second sample drawn is 0.272702, and what's the probability of getting rejected by that sample? So it's zero point 0.6. So this branch will be 6513. So if you add that branch 0.2702 times 0.6513, you should get your answer. Okay, so it's a bit of a complicated answer. So I'm just going to use the previous answers. Could go that plus 0.27, so this times this, and I should be study mode. So 0.7842. So it's a very tricky. This is a very good question. It's a bit tricky. Which plan do you recommend that Kira use? Please explain your answer. Now, anything reasonable will be fine. I would personally recommend which plan do we? I would suggest they do double sampling because it increases the chance of Kira weeding out the defective potatoes. Okay, because the first plan, I don't believe it's very good. Okay, because this is more, it's a more foolproof way of doing things. So hopefully that helps.